here. Okay. So we're going to fill in the rest of the chart, then we'll have the chart done. Today's our last day in new notes. We're learning about this equation of a circle, which we'll talk more about, but like I said, we could just probably throw it on here right away. So, so the ones, again, just to remind you guys, the ones above here, these are all talking about angles. These three are all talking about segments. So they're talking about the length of a line. So that's kind of important to be aware of. Like, so what am I asking for? I'm asking for a segment length in this case. So these are all segments. Whoops, if my pen would work.
Watch this. Bam.
So these are all talking about our segment length. And so we talked about this last class. Again, this is nothing new. So the two parts of the chord. So I said two parts of chord one get multiplied together. So make sure it's clear that that's a multiplication there. And then the two parts of chord two. And again, this is all multiplication. Now the next one is the secants outside the segment. So this is the one where we do take the outside part and then the whole together. So in this case, I'm going to say AB gets multiplied by the whole segment, which is AC. And the same thing on the other side, AC, or AD, sorry, gets multiplied by AE. I'll move out of the way in a second. And it might be good to point out that I want to make sure I add when I'm talking about the whole segment. So like if I'm trying to figure out the whole segment, this is AB plus BC. So I'm adding it, don't confuse that and multiply, whoops. So that whole segment is what we're looking at there. And again, a lot of this stuff is very logical, but it'd be a lot to remember. So again, that's why we're writing everything down here. And I am going to allow you guys to use these sheets, so you have to make sure you guys have that, okay? Our next one is the tangent, and since the tangent doesn't have two parts, it's on its own, we said we just multiply it by itself. So JK gets multiplied by itself, which just means it gets squared. And then again with the secant, it's the outside part, so JL times the whole thing, which is JL. No, JK's the tangent. Oh, got it. Okay, so thank you. JL here, thank you. Oops. Good catch. J, if I could not keep erasing. JL, thank you.
No problem.
So the outside times the whole. All right, and like I said, the new thing we're learning today, we'll just put the formula on here, is the equation of a circle. And again, this is maybe sounds like it'd be difficult how to graph a circle. I will not be judging you on your drawing of a circle capabilities. Most of the time the circle ends up looking like kind of like a lopsided square. It's okay. But we're gonna graph the circle, and it's really not that difficult. So we'll put that formula down here, and then we'll talk about it more in class today, but let's write it down. So make sure you write it down correctly. So it's x minus h squared plus y minus k squared equals r squared. And again, this is brand new to you guys, so it probably doesn't seem like anything makes any sense. Put that little pendant over. Okay, so I'll explain, where the different letters come from, because obviously x and y is a coordinate point that we know, but the h and k, if you look at, and it's probably hard to see on this little drawing, the h and k is the center of our circle. So if I know the center, I just would put it in the formula as h comma k. The x and y are just any points on our circle. So there's multiple x and y's we can use. Any idea what you think R stands for? Yeah, R is our radius. R makes sense with a circle. We have the radius. Now notice in the formula the radius is squared. So the radius is kind of hiding there. So that's important to... Okay. So you guys can set this aside for now. We're actually going to do a scrimmage later on. You'll probably want this for the scrimmage because it's going to cover these last couple of sections here. So hang on to that. You guys can use this on your scrimmage today.
Motorcycle back there.
You gotta wake up, buddy.
Okay, guys. So our warm-up question is asking us to do the distance formula. The distance formula it's been a while since we've done that, but we did it earlier this year. And the distance formula is really closely related to circles. So you're going to notice a really strong resemblance to the circle equation. So I'm going to write the distance formula down. You do not need to know this for our test as far as, now that I say that, I'm worried that, I don't think we do. So take a minute to do the distance formula. I'll double check. We might have, no, we won't. We'll have the circle formula. It looks like a bodyguard. It's like he's got something really valuable in there.
You look like you're a bodyguard. Like he's getting
getting his jewels, his precious jewels out of his locker. And
I want to know what it is.
Now, when we do this, you guys remember that these coordinate points are like, we call them like x1, y1, and x2, y2, because we have two sets of x's and y's. And we're going to put all that into our formula, which again, distance formula we've done before, so this should not be like new stuff to us. And sometimes the number works out nicely. I think this one does. Sometimes it does not, and that's okay too. You just have to be careful with your order of operations, where you put everything. So x2 minus x1. So I'm subtracting a negative, and that's going to end up becoming a plus. So careful there. So in the middle of the formula is always a plus. y2 minus y1. Okay. Now when I do negative 6 minus a negative 2, that really becomes negative 6 plus 2. Now when I do this, I do the parentheses before I square it. So I'm going to do negative 6 plus 2 first. Negative 6 plus 2 is negative 4. I'm going to square that. 7 minus 4 is 3. I'm going to square that. But now careful, when you square a negative, it always becomes positive. Now if you just put it into your calculator without any parentheses, it's possible your calculator does that wrong, so careful. Negative 4 times negative 4 is a positive 16. 3 times 3 is 9. So I find out this is the square root of 25, which is to just be 5. So the distance between these two would be 5 units if this is a coordinate system. Not like inches or anything, because we don't know like if these were inches or how far apart they were, but that's how many units it would be in that case. If you're comfortable with distance formula, circle equation actually, like I said, is very, very similar. So I'll show you guys how they're similar here in a second, but we just wrote that equation down. We kind of wrote some things down already about this. Again, we're not doing a ton of examples because I don't think this is a super tough idea. Hopefully, there's more complicated things we can do with circles, but we won't get into that. We're just kind of doing the basics of them. So our equation of our circle, our standard form, I might back some of these up here. And we just wrote it on our chart.
Cannot comprehend the size.
Just so I can have it all on the screen at one time. Now, my pre-calc students actually do a lot with circles, guys, and their equation doesn't show up in what we call standard form. All of your circles today will basically be in standard form, or you'll have all the information to put them in standard form. So, again, we just wrote this on our chart. We're writing it again. And we said R was the radius. Now remember the diameter cut in half will give us the radius. Now in our equation, the x and y are actually going to, we may put variables or numbers in there, but in our final equation, kind of like in y equals mx plus b, we're going to leave the y and x and y as variables. So, so this x and y are going to stay as variables in our standard form. So in our final equation, again, like kind of like y equals mx plus b, we put the x and y back in as variables. And then finally the h and k is our center of our circle, which I mentioned before. But notice in the formula, there's a minus sign in front of them. So our center of our circle is h and k, but the minus sign is kind of confusing. So that's the center of our circle. So they kind of look like they're the opposite signs. So let me show you guys just a kind of a quick example of what I mean. So if I have So if we do x minus 5 squared plus y plus 3 squared equals, let's do 36 over here. Let's identify the center and the radius. So like we're going to talk about those important parts of our circle. So I don't think they know any of this information that we'd want to know. If we wanted to graph this circle, what would we know about it already?
Radius is 36.
Is the radius 36? You're close, but is it?
Oh, 6.
Yeah, so like Tucker pointed out, the radius, that connects with this 36. But if they tell us it says r squared is 36. So if we're trying to figure out the radius of r squared is 36, that means we take the square root, so r would actually be 6 in this case. So this circle would be 6 units long in terms of its radius. Okay? Then the center of this circle is probably the other piece we're going to be able to figure out, but that's also a little bit tricky here. Anyone think they want to take a stab at what the center is? What do you think?
The center is, like the points are -5 and 3.
You guys agree with him?
Yeah.
He's super close.
-5.
Okay, so this is where the center is a little confusing. Notice in the formula there's a minus sign here. Yeah, so we actually have to look at it as like the opposite of what it looks like. So technically, like think about covering up at x minus. So what's the h going to be?
5.
5. So our center is actually going to be 5, comma, and how about this one? It's going to be a -3 instead. So what it looks like is it's always going to be like the opposite. So that's a little bit confusing. So I appreciate Luca giving a college try there and understanding that that's a really easy place to get mixed up. So it looks like the opposite sign. So I'm actually going to give you guys some graph paper, and we're going to graph this, and then we'll take a little break. This graph paper is for your homework tonight, but you only need 3 of the graphs, so I figured I'll just give it to you guys now, and we'll graph one of them. You only need, like I said, you only need 3 graphs for your homework tonight, but I'm going to graph this. So we're going to graph based off of our center and our radius.
Just like that, just like that.
Okay, so if we're going to graph this, we're going to start with the center. So we discovered the center was 5, -3, based on what we figured out now that we're learning things about this. So 5, negative 3. So over 5 and then down 1, 2, 3. So there's our center. And what we're going to do from there, we said the radius was 6, because square root of 36 is 6. The radius is 6. So what we're going to do, and it's only, you can only count up, down, left, and right. You can't go diagonally 6. Like there's no way to count that way. So we're going to go up 6, down 6, left and right 6. So from here, from the center, I'm going to go 1, 2, 3, 4, 5, 6. So there's one of my radii. I'm going to go out. 1, 2, 3, 4, 5, 6. I'm going to go down. And I'm going to go to the right. I'm off my graph, but that's okay. And now we're just going to kind of try to sketch a circle as best I can. And again, it's not like I'm going to be like, oh, worst circle ever, 5 points deducted. It's going to be, as best you can. I usually think the more times I go around, the better the circle gets, but I don't know if that's true. So that looks pretty good. See, sometimes when I go around more than once, it looks okay. But I mean, I've been drawing circles for 25 years, and this is as good as my circle gets. So, so it's okay if you're. It's gonna go off. Yep, that's okay.
Perfect there.
I got to this perfect.
All right.
I have one curve that's still off.
And so again, no judgment. I will not take off